This video covers best practices for building a SketchUp model for daylighting analysis in Sefaira. Let's start by asking, what does the analysis engine look for in the model in order to do the simulation? The answer is a few things. One, it needs to understand the exterior envelope, including opaque and translucent or glazed surfaces. It also needs to understand any shading elements on the exterior that will block daylight from entering the building, as well as any interior walls or partitions, including glazing on the inside, that could affect the daylight distribution on the interior of the building. You can check all of these elements by looking at the entities. Simply click on the entity palette and show and hide entities, and you can see the exterior envelope, interior partitions, and any internal glazing. Also be sure to put the ground of the building at z=0. So light, of course, reflects off the ground plane, which impacts daylighting, and Sefaira automatically adds a ground plane for daylighting analysis at z=0. So there's no need to physically model a ground plane, simply put the ground level of your building at that location. If you want to do room-by-room daylighting analysis, you should divide the floor plate of your building into individual rooms. So you can see here that each room and area is modeled individually as an individual plane. The reason for this is that if you don't split the floor plate into different segments, it may appear as if daylighting is bleeding across an interior partition. And the reason for that is that in order to get a smooth gradient on the daylight analysis, Sefaira interpolates across different sensor points. And if there are sensor points on either side of an internal wall, it could appear as if daylighting is going through the opaque partition. So to avoid that, simply split the floor plates along room boundaries. One other thing to be aware of is that simulation accuracy depends upon the geographic extents of the model. What that means is, if you were to put another building, say 1,000 or 2,000 feet away from your main model, that will actually affect the accuracy of the daylight simulation on your primary model. And that's because the scope, the geographic scope of the analysis is much larger, which actually has an impact on the radiance settings. To avoid this, simply model the geometry in the immediate vicinity of your building. So if you do need to model a surrounding building because it will provide shading on your main building, that's fine, but only model the immediately adjacent buildings that will directly provide shading. Finally, a note on complexity. Unlike energy modeling, daylight analysis is not directly related to the number of planes or zones in your model, meaning that it can handle models with much greater complexity. This is one of the reasons why you see different analysis modes in the plugin. If you have a model that is perhaps too large for energy analysis, you can switch to the daylight-only analysis mode and see if the model works there. One note on the technical side. Sefaira uses Radiance as the daylighting analysis engine, which is a validated reverse ray tracing software. If you're looking for more information on the radiance settings that Sefaira uses, visit Sefaira's knowledge base at support.sefaira.com.